Hello, and welcome to the Space Gas training video. In this tutorial, we'll guide you through the gap element, one of the new features introduced in Space Gas 14.2. Gap elements are defined by a tension and/or compression gap which must be taken up before any axial force is developed in the member. Consider a scenario in which a column is connected to a horizontal beam, designed with the intention that the column can bear lateral loads but not vertical loads. This connection is characterized by a slotted connection, allowing the vertical movement of the beam to be independent of the column's movement. Consequently, even though the column is connected to the beam, it does not receive any axial load transferred from the beam. In such cases, gap elements are ideally suited for modeling purposes. You can designate a member as a gap member by double-clicking on it and then selecting Gap as the member type in the Properties form. Note that there are two unique attributes to consider: the gap tension limit and the gap compression limit. These limits must be reached before any axial force is developed in the member. In our example, we can set the gap to match the length of the slotted connection. Let's proceed to analyze the model and observe the results. First of all, we don't see any reaction at the base of the column, indicating that there is no axial force in the column as expected. Under the current load case, the node's movement would typically place the column under compression. However, if the movement does not exceed the compression limit, no load is developed in the column, which is exactly the case here. On the other hand, if the movement of the node exceeded the compression limit, axial force would have developed in the column. In fact, we can give it a try by changing the compression limit to a quite small value, say 0.01 mm. Now we can see axial force developed in the column. This simple example effectively demonstrates how gap elements function. In the second example, let's look at a crane model. When modeling braced steel frames, such as a crane grillage, it's common for bracing to become overstressed in the model due to minor deflections in the main beams. This issue is particularly prevalent in bracing the top and bottom flanges of deep beams, where the beam's flexure causes a slight axial displacement in the bracing member, leading to a significant axial load. The primary function of the bracing is to counter lateral loads, while the girders are meant to withstand vertical bending loads. With the introduction of gap elements, you can now assign gaps to the ends of members. This feature is especially beneficial for bracing members, as the bolt hole tolerance often significantly reduces bracing loads, effectively redirecting bending moments back into the main girders, where they are designed to be absorbed. This is the end of the video. Thank you for watching.